Hey friends, nice to see everyone again. And today's topic is the systems of linear inequalities. And I would say that in many cases, systems of linear inequalities are even simpler than the systems of equations. Okay, and why is that so? Because basically systems of linear inequalities are about, if it's in one variable, today we'll talk about the ones in one variable. Just because they involve variable and the systems of equations are in kind of 2 or 3 or more variables, yeah? We could have many inequalities basically with one variable, and we'll pick the interval or the values of this variable which would fit to any inequality in this system. So that's the basic approach, okay? Later on, we'll talk about double inequalities. Later on, we'll talk about the quadratic ones, which are also very interesting things to work with. But now let's get started with the simplest things, okay? So probably the first example could be like this. Yep. So 2x plus 3 is greater than or equal to -1. That's the first equation, inequality. And the second one, 5x is less than, let's say, 40. Again, the basic approach is like this. We solve each single inequality separately and then see how are they placed on a number line, simply speaking, okay? In this case, if I take the first inequality, let me enumerate them, the first and the second one. Okay, so with the first one, let us subtract 3 from both sides, okay? With that we'll get 2x is greater than or equal to -4. And then the other one, 5x is less than 40, we just divide both parts by 5, okay? Which is reasonable and safe because 5 is positive number, so we don't need to take any other precautions at this point. Just divide and see what happens. So x now is less than 8. So this is how our system transformed. I wanted to do the first one only up until then, but I did two together. It's okay. Next step. The next one. Again, divide by 2, the first equation here, in the first inequality. Divide by 2. Oops, sorry. Understandable, yeah? And we get x is greater than or equal to -2. X is greater than or equal to -2. Okay. And the bottom one, again, x is less than 8. So that's what we've got. Now, we could use kind of 2 number lines or 1 number line, whatever is suitable, whatever you like more, basically doesn't matter. Let's do this, a number line. X. And then 2 is over there. Black point or filled in point, okay, because it's included greater than or equal to, remember, right? So it's -2. And then 8. I'll do on the 1 number line, okay? On 1 number line. Mistake. 8 should be a blank non-filled dot, not filled point, like this, okay? And then let's do the shading. I'll probably do it this way. Greater than or equal to 2, I'll pick orange color, or kind of yellowish orange. And I'll do shading this way, to the right. So again, especially if you like some beautiful stuff, the inequalities is a good way to arrange things nicely. So you could have some fun. Okay, then the other one, less than 8. Let me pick the red color. I make it slightly transparent, okay? And I'll shade to the left of 8, less than 8, okay? To the left of 8. So this would be my shading here. It could look bigger, smaller, whatever. So I just made kind of the same height, those. Shading things. And yeah, we just got this inequality, this interval, in which we have numbers that are suitable to both inequalities. Like 0 is greater than -2, greater, less than 8, less. So basically, 0 fits. If you take -1, it also fits. If you take 5, greater than -2, yeah. Less than 8, sure. 7, less than 8, sure. Greater than -2, sure. But if you pick, for example, 10 over there, so 10 is greater than -2, sure, but less than 8, no. Okay, that's why these are the borders of our interval of solutions, okay? And if we write the answer, again, we could do it in two ways. So the first way A to write the answer is as double inequality, kind of x is greater than or equal to -2, less than 8. Sometimes people also say -2 is less than or equal to x and x is less than 8. But I really like to start with x. X is greater than to the left, x is less than to the right. Okay, this is the first option of the way to write down the answer, and the second one is basically x belongs. Okay, the interval notation, x belongs, and it's from -2 square bracket and 8 round parentheses. Again, round parentheses stand for the number which is not included. Blank point, strictly less. Okay, this is the rule. So that's it, solved. We'll have more practice, but today let me show you one more thing. Okay, let me show you one more thing. So this system, I would probably, just a second, like this. I'll squeeze. Oh, I cannot do it. Guys, please go to the left. Okay. Let me squeeze it to over there. You could still see it if you like. The next one. Would be like this. 5x is less than -10 and x plus 4 is greater than 16. You could try solving it on your own, and then let's think of it. What does it mean eventually? So this guy is kind of mocking at us. Could you solve it? Okay. Succeeded? Well, from the first equation, from the first inequality, we would say that x is less than -2, right? X is less than -2. From the second one, x is greater than 12. X is greater than 12. If we try drawing this stuff on a number line, we'll get something quite weird. Since -2 is over there, blank dot, -2, positive 12 is somewhere over here, scale doesn't matter, over here, and what we need, less than -2, it's there, right, to the left of -2, greater than 12, to the right of 12. But the system itself means that those conditions should be working simultaneously at the same time. So the number should be at the same time less than -2 and greater than 12. Obviously, that's impossible, right? there are no overlapping intervals means there are no solutions, simply speaking. Okay, and in this case, often we write like either no solutions or x belongs to empty set of numbers. No numbers are suitable for x here. There is no such an x that it's at the same time less than -2 and greater than 12. Okay, so sometimes it also happens when you solve inequality, it's not solvable. You cannot do that. No problem. That's the way to train. Sometimes real life situations are also not solvable. So what? We could just wait and see. Maybe things would improve step by step. Okay, that's why math is kind of cool, because learning this stuff, talking about logics, talking about some parallels in math life and in real life, we could see that it could teach us some interesting things. Okay, well, if there are any other questions, please feel free to leave them in the comments. I'll be happy to see any of your reactions. If you have any suggestions what kind of problems to solve, please give those ones, and I'll be really happy to read whatever you comment. Okay, wish you all kind of success in your studies now. Okay, that's it for now. See you and bye.